You want to optimize that. So here we go. So for you guys at home, we've got an optimization problem. This is on the, so we're continuing with modeling with functions, and you'll see that this one will involve a quadratic. So if you read the problem, a farmer wishes to create a rectangular pen using the river as one side. The farmer has 400 feet of fence. Write a formula for the area of the enclosed pen in terms of x, and x is the side of one of the horizontal side of the pen. Find the area if x is 50 feet, and so on. So let's get started. So here's my steps. When I do these problems that are more geometrical in nature, what I like to do is this. This is different than those linear problems in terms of what's fixed and what changes. First thing I'm going to do is draw a diagram. Even if they have it, I'm going to redraw it, and I'm going to label what is known and unknown. Okay, so when I work these problems, that's how I would work it. So I've got the rectangular pen. I know that this side is x. If this side is x, what would you call this side? X. And I'm going to just put something here. Well, I'm going to call it, because it's not necessarily x. Nobody said this is a square. It's rectangular. These two sides are the same. This length here, I don't know, so I'm going to call it y. Okay? You call it whatever you want, L for length or something. I'm not using y for my y anyways. I'm using something else. Okay. So I've done that. The next thing I'm going to do is determine what you are trying to find. You know, what is it that we're trying to find? Well, in this case, it says that we want to write a formula for area. So now that now helps me define my variables. So now we know we need an area, and we need to know what is x, okay? So the area in this case is area of the what? Pen. And what's the shape of it? Area of rectangular pen. So it's the area of rectangular pen in terms of x, right? Which is one of the sides, and x is the horizontal side of the pen. So yeah, I've defined these, but I actually will write out like what it actually equals. So what is it I'm trying to find? I know I'm trying to find area, and so when it's geometrical like this, it's more of a geometry problem. I got to know, well, how do I get area of a rectangle? So in terms of this, as I write this definition, I'm going to actually write how I would get area. So how would you find the area of that rectangle? X times y. And now this is going to help you kind of write your formula. So this is different a little bit than those other problems we did where we had a fixed amount and a changing amount. Yes, there are things that are fixed and change, but I take a different approach on the geometrical problems. So I've still defined what it is, but then I know that it's area that I want to find, so I write out area based on my letters. Now you guys might have used x, x, and L, then you would have said x times L, whatever you want to call that vertical length. The problem is when you write an equation, you only want one variable on this side. So now this next part is critical. We have to use other information to write our equation only in terms of x. So there's something else from the problem that we haven't used. So we basically need to come up with another equation so that we can then make a substitution, because I only want x's over here. The y is important, but y is still depending somehow on x. Because right when the farmer goes to use his fencing, this length and this length will then depend on how much he uses there. And how much will that be? So let me ask you this. What do all three of those sides have to add up to? That's what you have to bring into the problem. So you're going to usually have to, this step forward, to figure out how do I bring in the other information. Well, the other information is that y plus 2x has to equal to 400. right? Because that's all the sides of the fence. And we don't want to know what y plus 2x is, we actually want to know what y equals. So y, so you might could have figured it out by looking, but if I solve for y is 400 what? Minus 2x. And that is what I need to put in here, because I only want x's in my equation. I don't want x's and y's. So the hardest part is going to be to use other information to write our equation only in terms of x. So I made a different equation based on the problem, right? The word problem. I wrote that out, and I used that to solve for y. So if you get different unknowns over here, you only want one unknown on the right-hand side. And then that's the trick to the problem. Once you get that, you're done. Okay? So it's going to be x times, I'll take y out, 400 minus 2x. And that gives me my dimensions. And then you can plug in, right? So if you want to know what's the area if x is 50, well, you plug a 50 in there. Obviously, we know if that's 50, then that's 50, then that's going to be 300, right? So you could do that, so we could find the a of 50. So if we do that, it's going to be 50 by 300, which gives us what? I think 15,000 square feet, right? Whatever it is. Okay, because that was one of the questions. Yes? If they give it, you should. Yeah. It says, see what it says too in the thing, in the problem. Yeah, it should be square feet, right? Now, how do you get the last question? See, this is what we do in calculus, but you don't need calculus for it. How do we get the last answer? Find x so that the enclosed area is a maximum. Because, right, isn't there going to be some dimension that makes it perfect, right? That gives you the biggest area. Because if I'm a farmer and I got a bunch of cows or whatever that I want here, I don't want, I don't want to do this. I don't want like a small x, and then just a strip of land like that. My cows ain't going to be able to move, right? I'm not maximizing my area there. So there's some happy dimension that I pick for x that gives me the biggest land to use there. How do you figure that out? So, anybody know for plus 1 million minus a million, what type of graph that is? This is, I'm adding this on. They may not ask you this, I just want to talk about it. Anybody know what that graph is? It is a quadratic. That opens how? Opens down. If you distribute your x, you get a negative 2x squared. See, it's a quadratic that opens down. Now, when you pick a point, it's not xy, it's x area. So whatever point you pick on this quadratic, it's x area. Guess which point is going to give you the highest area? The top. And you could get that by using your calculator. I don't know that they're going to go that deep. We'll talk more about that later. But that last question is what we call optimization. That what is the dimension that optimized gives us the best conditions. So this is the rectangular pen problem. I'll do volume on Friday of an open box. So we'll talk about that on Friday. Okay. A reminder, just in case you watch, if you have construction paper, like the yellow, blue, green, you know what construction paper is? Bring that on Friday. You guys at home, if you got construction paper, a sheet of construction paper, have it ready when you watch the next video that I send out on Friday. Okay.